Wednesday, halfway, endure. Today we're going to complete the example of force undamped vibration. Okay, so this is the last probably 20 minutes on mechanical vibration. Then after that, we are going to go into planar rigid body motion. Homework 2 has been posted. Okay, so I'm going to complete this problem. Okay, so let me go through this again. So we have electric motor turn at an eccentric flywheel, which is equivalent to an unbalanced mass of 0.25 pounds or weight located 10 inches from the axis of rotation. If the static deflection of the beam is 1 inch due to the weight of the motor, okay, determine the angular velocity at which resonance will occur, and the motor weight is 150 pounds. Neglect the mass of the beam. So we have completed that. The next part that we're going to do, okay, we are going to determine the angular velocity of the flywheel such as we can produce an amplitude of 0.25 inch. What bothers me a lot is some of, or including myself when I was your age, I can't visualize this at all. In the sense that some of you accept the concept that it's a flywheel will cause what? Imbalance. Am I right? Right? In general, what you see on a flywheel, it will always cause imbalance. Okay. So thank God for YouTube and knowing what to Google. Is it Google? Yeah. Okay. I have found something that will interest you. Okay. So what you see over here, let me restart this. Okay. What you see over here, can you see? Yes. Okay. Watch my arrow. Okay. What you see over here is a motor. And what you have over here is an arm. At the end of the arm, there's a weight. Okay. And then this is attached to a horizontal beam. And this horizontal beam is attached to 4 springs. And before the motor is turned on, right, is at its what? Equilibrium position. Okay, so what you will see now is when the motor is turned on. I don't know whether can you get volume. Let me see. It is more interesting with volume. Okay, let me see if you can get music. If I do this right, you get music. Do you have music? Okay, let's see. Okay, let's go. Okay, you can see the counterweight, right? Because of the unbalance. If without the arm and the mass, right? Some of you are giggling. Unbelievable. Okay, but anyway, without the mass, right, and the arm, you will not have this sort of oscillation. Are we clear? Okay, so let's go through it again. Okay. Okay, you can see, so you get that oscillation. Hopefully this will help you visualize the problem better. Okay. Okay, I will post the link on Avenue. Gentlemen at the back, are you okay? Okay, he's okay. You're in my class? Okay. My student safety is my responsibility, okay? Right. So now you can see how it works now, right? Right. So once I turn on the motor, it will start to what? Oscillate, and that's what we are dealing with for this case. The last part of the problem that I'm going to attend is we're going to determine the angular velocity of the flywheel, okay, such as to induce a amplitude of vibration of 0.25. So we know the amplitude okay, so it highlights the angular velocity of the flywheel. Okay, so the flywheel we know the expression of the flywheel that will generate is F naught over K divided by 1 minus by omega naught squared or omega naught over omega n squared. Okay, we are going to focus on this expression. And we have found our K already. Okay, the K we have determined. The K we determined was, if you look at last week, was 1,800 pound per feet. Okay. And we know that the amplitude, right, the amplitude that we're going to produce will be equal to 0.25 divided by 12. So 0.25 divided by 12 is equal to 220.833 times 10 to the power minus 3. Now we have converted this to feet. We have to do this in feet because the what? The stiffness is in what? Is in feet. So we have to convert this to feet. So for this question, we would like to determine omega naught, right? And we know, we are aware that F naught is equal to M R squared omega naught, right? So we don't know what is our F naught value yet, okay? Or FR, sorry. I wrote wrongly, okay? So we can formulate this and let it be a function of the variable omega naught. And we know now for this, let me write, this is due to the what? Okay, this is due to the unbalanced what? Mass. Not the entire weight of the what? The motor. Are we clear? Right? So this will be equal to the unbalanced mass is equal to, given to us as what? 0.25 in weight. So convert to mass. So 0.25 divided by 32.2. Then multiply by the radius. So the radius is what? 10 inches. We have to convert this to feet also. And then we have our omega naught squared. Okay. So over here, this factor is to convert pound to slug. And this one is to convert inches to feet. Okay. So this will be equal to 0.25 divided by 32.2 times 10 divided by 12 is equal to 6.47. Okay, times 10 to the power minus 3 omega naught squared. Okay. So looking at what we have, right? So we have our amplitude. We have our function of F naught. We have our K. We have our omega naught. And omega n, we don't have yet. So omega n, we did it last week. So omega n was what? Did we find omega n? 19.658. Okay. So 19.658 radians per second. And this is from week 03, Monday. example, okay? So in case you're wondering how we get that, right? So from here, we have every value now. So all we need to do is to put into, I'm going to make my life easy rather than starting from a new page. So we know our amplitude is equal to 20.833 times 10 to the power minus 3, right? And then this will be equal to F naught. F naught is equal to 6.47 times 10 to the power minus 3 omega naught squared, and then divide by K is 1800. Then the whole thing will be 1 minus, and we don't know what is our omega naught, but we are aware that our omega n is 19.658, and the whole thing squared. Okay. So when I bring the 1 minus by omega naught over or 19.658, putting squared, and this will be equal to 6.47 power minus 3 divided by 1800 divided by 20.833 power minus 3. This will be 172.536 times 10 to the power minus 6 omega naught squared. Let me do that again. 172.536. 6.47 power minus 3 divided by 1800 divided by 3.833 power minus 3. 172, yep, okay. So once we have this, we can write down 1 minus by or 1, we bring it over to the other side, 172.536 times 10 to the power minus 6 omega squared plus by omega, sorry, I forgot omega naught, okay. Omega naught squared divided by 19.658 squared, okay. So this term over here, 1 will be equal to 1 divided by 19.658 squared plus by 172.536 power minus 6 is equal to 2.76 omega naught squared. I'll do it again, okay? 1 divided by 19.658 squared plus by 172.536 power minus 6, 2.76. Okay, so omega naught is 1 divided by 2.76, then square root is equal to 0. Did I do something wrong? You all find any mistake? I get 0.6 02 radians per second, and my notes told me that it should be 0.25. You all got the same as me or no? Yes? Okay, let me check again, okay, but the form is correct, or the sequence, let me check later on, okay? It seems to be off a bit. Oh, yeah, okay, yes. Say it again. Yes. 6.47 power minus 3 divided by 1800 divided by 20.833 power minus 3